Today, we solve system of equations using substitution. Let's do it, and let's do it now. Mercado math, it's time to do some math. Let's Merca do it. This isn't the 5th floor. Oh, didn't see you there. Well, while you're here, let's solve this system. So this is a system. Now, there's a lot of different ways to solve a system, but for this one, there's a very simple way to do it. So we're going to talk about some of the ways. The most basic way, the first way most people learn, is graphing. If you want to graph these two, these are in slope-intercept form. It's not so bad. However, the issue with graphing, you got to have graph paper. You got to hope it's not a fraction or decimal, because graphing those isn't very simple. And the numbers can get very large, because if you have very large numbers like hundreds or thousands, you can't physically graph that easily. You would need a computer. And in real life, the numbers aren't always this small. We're going to keep them kind of small today just so you get the hang of it. But technically, you could graph this. There should be a graph here. And you would just find where they meet. When you solve a system, you are finding where two lines intersect. That's what we want to find. That's what's kind of nice about graphing it. If it's graphable, you can visually see where they meet. But we're going to do it a different way. So for the substitution method, we are literally going to just substitute. This says y equals 4x plus 5. This says y equals negative 2x minus 1. The key here, y equals. I know what y equals. I am trying to find where they intersect. I am trying to find the coordinate x and y, and they already kind of told me one. Hey, y equals 4x plus 5. So since I know y equals 4x plus 5, I'm literally going to take this one, and instead of y, I'm going to write what y equals. What does y equal? Y equals 4x plus 5. So instead of y, I'm going to put 4x plus 5 equals negative 2x minus 1. And once again, all you did was replace the y with 4x plus 5. If you want another visual of this, y equals negative 2x minus 1. Same thing, but once again, instead of y, I took this. Y equals 4x plus 5, and instead of y, I put that 4x plus 5. That is substituting. You are literally substituting one thing for the other. And now, it's just solving an equation. You were doing this in chapter 2. Some of you, this is what you think of algebra, is just solving an equation. So I'm going to solve this equation. 4x, negative 2x. I have x's on both sides. I'm going to add this 2x. Whatever I do to one side, I do to the other. And I now have a 6x plus 5 equals negative 1. Keep going. I have this plus 5 to get rid of. Remember, get rid of what's furthest away or on the same side. Minus 5, minus 5. I now have a 6x equals negative 6. To finish this off, divide by 6. Divide by 6. I'm a little tight on space. And I get an x equals negative 1. Now, once you get x, you got to get y. Okay? That's the thing. Remember, you are trying to find the point where they intersect. Points are made of x's and y's. I found x. I have to get y. And how do you find y? Well, it's called substitution. We're going to substitute. You can plug it into whichever one you want. Because both of them say y equals. Y equals. So it's easy to plug it in. I'm going to plug it into the top one, though. So, y equals 4x. I just found x. X is negative 1. Plus 5. That's y equals negative 4 plus 5. Negative 4 plus 5, and I get y equals 1. And you have your answer, 1 and negative 1. You can leave your answer like this. Most people are okay with this. A lot of times, though, you will see it as a coordinate because, once again, these are two lines, and you're finding the point of intersection. So a lot of times, you will see the answer written as a coordinate because it is a point. So you would see negative 1, 1. Now that is a very basic type of substitution problem, but the ideas are all going to be the same. If you have y equals, if you have x equals, you take it and you plug it in. Okay? You substitute. All right, let's go to our next problem. So, here are two equations. Once again, if you really wanted to, you could graph them, but this one's in standard form, so it's not the easiest to graph right off the bat. Not only that, if you were to try to put this in slope-intercept form, you'd get a crazy fraction, you get a decimal, and the moment you have to deal with decimals in graphing, you're going to be off just a little bit. It's not the easiest to graph things like thirds, fourths, and fifths. You could estimate a little bit, but we don't want to estimate. We want exact numbers. So we are going to substitute. Well, what do we substitute for this one? And the key is just think about what you're looking for. You want x, you want y. That's what you're looking for. You're looking for the point where they meet. You're looking for an x and y. And right here, I see a y equals. That is the trick to substitution. If you have an x equals, y equals, the important part of your job is kind of done for you. And this is slope-intercept form, so it says y equals. So I'm going to take that, y equals 3x plus 1, and I'm going to substitute it into the other equation. I'm going to take it and drop it in there. So I'm going to rewrite this first equation. 2x minus 4y equals negative 14. That is the first equation. I just left this big y parenthesis set there. And the reason for that is instead of y, this y, I'm going to write what y equals, and y equals 3x plus 11. So 3x plus 11 will replace the y that was in there. And now that this is done, I'm just going to solve this like a regular equation. Nothing special about it, right out of the chapter 2. 2x, we distribute. Don't forget to take that negative for the ride. Negative 12x. Negative 4 times 11 is a negative 44 equals negative 14. We keep going to solve it. I have a 2x minus 12x is a negative 10x minus 44 equals negative 14. Keep solving whatever's furthest away but on the same side. Get rid of it, so there's x. Get rid of that 44, so plus 44. Plus 44, I get a negative 10x equals 44 minus 14 is just a 30. And I'm a little tight on space here, but I will still try to fit it. Divide by negative 10, divide by negative 10. And I get an x equals negative 3. So now I know x equals negative 3. Super. That's the hard part. You're ready. Technically you're half done because you have x and you need to find y. But finding y is not going to be this much work. Finding y is going to be as simple as just plugging it into one of these equations. You can plug it into whichever equation you want, the top one or bottom one. However, if you're thinking a little bit and you're trying to solve for y, why wouldn't you go for the one that literally says y equals? This one is literally telling you y equals, so it's probably going to be a little easier to get y. You can do it here as well, but you're going to have to do some work to get that y by itself. So, y equals 3x. I just found out x equals negative 3. I did my work for that. Plus 11. That gives me y equals negative 9 plus 11. 11 minus 9 means y equals positive 2. And I have my answer. X equals negative 3, y equals positive 2. Remember, you can leave your answer like that. A lot of times, though, because like I said, this is a point where they meet. This is the point of intersection. You will see it written as a coordinate pretty often. So just be aware, it's the same crap. I don't think anyone's going to really be that upset if you leave it like this. But just be aware, same thing. And if you write it like this, it kind of reminds you that these are two lines. People forget that these are lines. You're graphing lines. It's just you're trying to not have to graph them. All right, next question. So here's another one very similar to the one you just saw. It's a little different, but once again, these are the ones I would use substitution for. You're going to learn other methods for this. Like I said, there's graphing, there's substitution, there's things called elimination. There's even ways to solve it with a matrix. But for you, substitution and elimination are going to be the most common ones. And substitution should make sense. So the way we do this, I have to find x and y, and I notice right away x equals. This x equals is your biggest hint that substitution is going to be the best way to do this. Because the moment I see that x equals, I now can say, hey, I know what x equals. X equals 5y plus 10. So once again, I'm going to replace this with that. So I'm going to write 2x. I'm just going to write this equation. 2x minus 4y equals 2. And the key is, I know what x equals. It says it right here. X equals 5y plus 10. So I'm going to take away that x and put that 5y plus 10 in here. Now that that's done, it's an equation. This is a, what, a three-step equation. Looks kind of worse than it is. 2 times 5y is 10y. 2 times 10 is 20 minus 4y. 10y minus 4y is a 6y plus 20 equals 2. I forgot the equal 2's here. I don't think that really matters much yet. Now that I have that, I keep going. I have minus 20, 6y equals different signs. Subtract, keep the dominant sign, negative 18. I'm very tight on space here, but you should be able to divide by 6. Negative 18 divided by 6, and I get y equals negative 3. So now I know y equals negative 3. I found y. Now that you found y, don't forget to find x. It's very easy to forget the other variable. You just did all this work. You got an answer that looks like that. You feel like you're done. You still need the other one, okay? So you can pick whichever equation you want to plug it into. Do I want to plug the negative 3 into the top one, or do I want to plug it into the bottom one? The top one says x equals. That's the easier bet. If I'm looking for x and there's an equation that says x equals, that's what I should use. And that's what I'm going to use. Well, let's just divide that up a little bit. X equals 5y. I just found out y equals negative 3 plus 10. X equals negative 15 plus 10. Negative 15 plus 10, different signs. Subtract, keep the more dominant sign. And I get x equals negative 5. I have my x. I have my y. You know where they intersect. These two lines intersect at negative 5, negative 3. If you were to graph this on graph paper, that's where you would find two lines meeting. And let's actually write this as a coordinates. Once again, you don't have to do this. I'm never going to be that pissed if you don't do it, but just be aware. If you see this, these are the same thing. A mistake that happens is because you found y first, people put the y, the negative 3 for the x, because they just forget. They think they find this first, so that goes first. Just remember, x, y. It's coordinates. There's your x. There's your y. All right, the next one we're going to do is a special one. But if you can do the ones we just did for substitution, you're in pretty good shape. So here's one that, honestly, I probably wouldn't use substitution to solve. It's not harder, but eventually you're going to learn another method after this that would be preferred to do than substitution. But you can do substitution with this. The way it works, though, is that you don't have a y equals or an x equals. What made the last three problems easy is that you had a y equals, you had the x equals, you had a variable by itself. So you're just going to have to do that on your own now. You have a y here and you have an x here. So most people kind of opt for the y by itself. You just get trained for that in slope-intercept form. So what I'm going to do is I'm going to put this first one in slope-intercept form. Minus 4x minus 4x. And I will get this brand new equation that is y equals negative 4x plus 8. And now I will be using these two equations for substitution because I just rewrote the first one in slope-intercept form. So this one's now ready to go. And now you're going to do what you've been doing. But it's that one extra step, sometimes two, that means that it's a little bit more work. And why I really wouldn't use substitution for this, but you don't know the other method yet, or maybe you do. But let's do it anyway. Y equals negative 4x plus 8, x plus 2y. I now know y equals negative 4x plus 8 equals 9. Once again, just rewrote this top equation, the red one, x plus 2y, but instead of y, I know y equals negative 4x plus 8, and then that equals 9. You solve it. I'm going to go a little quick on this one because solving equations you've done before. So x plus negative 8x plus 16 equals 9. Combine like terms is a negative 7x plus 16 equals 9. Minus 16, 9 minus 16 is a, where am I at? Negative 7. And then you get x equals positive 1. Let's throw that up here. Once you get x equals positive 1, plug it in. Now, it's interesting to plug it in. You have three equations now you can plug it into. The top, the bottom, and that middle one. These are the same, though. So, a lot of people don't pick this one because they think about the original ones, but these two are the same, so it really doesn't matter which one you plug it into. So like most people just stick to the two original, but you could plug it into here. In fact, I would plug it into here because it says y equals, but I'll plug it into this one just for the hell of it. 1 plus 2y equals 9. Remember, I'm putting that 1 there because it says x, and I just found out x equals 1. Minus 1 minus 1, 2y equals 8, y equals 4. You have x equals 1, y equals 4. Like I said, this one, you can still do it with substitution. It doesn't actually look like it was more work than what we've been doing. It was one extra step, but it's that one extra step that kind of makes it not the best to substitute with. It's not bad, but like I said, you'll probably prefer a different method when you see this in the future. All right, let's do one more, and then that's kind of it. There'll be a separate video for special cases. So here's one, looks completely normal, and we're just going to solve it. We're going to take it, y equals negative 2x plus 5, and plug it into that top one. We're going to take this y, throw it in there. 4x plus 2y, but y equals negative 2x plus 5 equals 12. So just rewrote that top one, but once again, instead of y equals negative 2x plus 5. And I keep solving. 4x, I distribute that 2, negative 4x, distribute the 2, plus 10 equals 12. Combine like terms, 4x minus 4x, and I'm like, oh crap. 4x minus 4x cancels out. And I'm left with this, 10 equals 12. And if you remember when you solved an equation, this is something that happens. This is it's not common, but it does happen. This does not make sense. It does not make sense because there is no solution. That's the null set. This has no solution. And if you remember what you're actually trying to find, these are two lines. You're trying to find the point where they intersect. And this is saying they don't. So if you take a second and think, hey, what kind of lines don't intersect? You kind of realize what these lines are going to be. They're still lines. They're just regular lines. But you realize they are going to be parallel. They will never intersect. What this is telling you is, hey, you have two lines, but at no point will they actually intersect. Actually, these slopes are negative, so if you want to make it a little more accurate, they're going this way. And they will never intersect. You will never see these lines cross and find that point because they never will intersect. That's what it is, no solution. If you remember what the other options are, we'll talk about that in special cases. So don't miss that special cases video. Coming up next, a punt. See if you can figure out what I'm drawing before I finish. I want you to know that for all you still doing work, I've noticed that it has been good quality. And I appreciate you guys who are still doing work. Those who are not doing work,